Welcome to Operations with Fractions Recap. For this video, we're going to be talking about adding, subtracting, multiplying, and dividing fractions with variables. So for the first one, when you're adding fractions, you need to make sure that you have the same denominator. In order to find a common denominator, you're really going to look for your LCD. Really, any common denominator would work, but if you find the LCD, then you don't have to do additional simplifying in the end. Now, think about it. What does 6x and 9 both go into? If the x is throwing you off, just think about what 6 and 9 both go into, the smallest number. That would be 18. Now, because you have an x in one fraction, you need to have an x in your LCD. Now we're going to multiply each piece by what's missing. Now think about it. You have a 6x. So 6x times what gets you to 18x? And that's going to be 6x times 3. What you do to the top, you have to do to the bottom. Now you have a 9 in the other fraction. So 9 times what is 18x? And that's going to be 9 times 2x is 18x. You're going to multiply everything together, so we're going to get 15 over 18x plus 4x over 18x. Now that you have the common denominator, you're going to keep the denominator and add the numerators. So you get 15 plus 4x. Now, in this case, you can't actually add 15 and 4x because they're not like terms, so you're just going to leave it like that. You can't simplify this anymore because, well, you can't factor anything, and you cannot cross out the x's because the x up top is attached to something else by addition. So if you really want, you might see an answer with the 4x first, but that's about it. So make sure when you're adding fractions, you want to find a common denominator. Same thing applies to subtracting fractions. It's the same thing. Find the LCD, multiply each piece by what's missing, keep the denominator, and subtract the numerator. Let's try multiplication. Now, when it comes to multiplication, you're going to multiply straight across. You multiply the numerators, you multiply the denominators, and then you would simplify. However, if you simplify to begin with, you'll save yourself a lot of simplifying at the end. I prefer to simplify with the smaller numbers in the beginning than to simplify with the larger numbers at the end. So what you're going to do is look at your coefficients. Now, you're going to simplify one top with one thing in the denominator. For example, I see a 3 up top and a 3 on the bottom. 3 divided by 3 is 1. So both of those simplify to 1. Now I also see a 4 and a 2. 2 goes into both 4 and 2. So 4 divided by 2 is 2, and 2 divided by 2 is 1. I also see x's. So up top, I have x squared, and on the bottom, I have x. If you think about it, these both have an x in common. So if I take away one x from both of them, I'm left with x to the first. And here, there's only one x to begin with, and x divided by x is just 1. And then you're going to go on to your last one, the y's. I have y to the first and y cubed. Both of them have a y in common. Y divided by y is just 1. And y cubed divided by y is y squared. Now that I did all that simplification, if you can actually read your handwriting, what you have left over is, on the left we have a 1, and we have an x to the first power over 1. On the right-hand side, we have a 2 up top, a y squared up top, and just a 1 on the bottom. From there, 1 times 2, your coefficients being multiplied is 2. X times y squared is xy squared over 1 times 1, or just 2xy squared. Again, you don't have to do it that way. You can multiply everything together first. So let's see if you were to actually multiply everything together first. 3 times 4 gives me 12. Then you're going to think x squared times y cubed is just x squared y cubed. On the bottom, you're going to multiply your coefficients in the denominators. You have 2 times 3 is 6. From there, y times x is xy. We just typically write these in alphabetical order for the variables to keep things neat. Now you can actually go and simplify. You have 12 divided by 6 is 2. With the quotient rule for exponents, x squared divided by x is x, and y cubed divided by y is y squared. So you get the same exact answer. It's just a personal preference of what you choose to do. When your problems get more complex, it is easier to simplify first. Last one we're going to go over is dividing fractions. Now, in order to do this, you have to change the division into a multiplication. And you're going to do that by remembering keep, change, flip. So we have 7x cubed over z times, and I'm going to flip it now, 3 over 5z cubed. Now, I did say before that it's easy as to cancel before you actually multiply. But keep in mind, if you look at this one, you can't actually cancel anything out because both of your z's, the only thing that they have in common, both of the z's are in the denominator. And you can only cancel if one's in the numerator and one's in the denominator. Please do not cancel from the beginning as it's still division because you have to change it to multiplication before you do this. Anyway, now that you keep, change to multiplication and flip, KCF, you're going to just straight out multiply. So 7x cubed times 3 is 21x cubed. Z times 5z cubed is 5z to the 4th. And then you would look to see if you can simplify there, but you can't. Nothing can be simplified. So to sum things up, when you're adding and subtracting, get a common denominator by looking for the LCD, keep the denominator and add or subtract the numerators. For multiplication, simplify first, usually it's helpful, and then multiply the denominators and numerators straight across. And then for division, you're going to KCF, keep, change, flip. Keep the first fraction, change the operation to multiplication, and flip the second fraction. And then just multiply the two fractions together. Make sure whenever you are doing any type of operations with fractions that you always want to see, can your answer be simplified anymore before you're done with the problem? And that's all for this video.